All right, so factoring part 3. So previous 2 videos, we started off pretty straightforward. What is the greatest common factor? What can we factor out from an expression? We got the hang of those really easy, right? The second video, well, what happens when the thing that we're trying to factor out is actually a binomial? Well, simple. We factor out that binomial, and then we have what's left over. Now we have a situation that's a little bit more dire. What happens when we want to factor something out, but there literally is nothing in common between all of our terms? Like number 9. We have 4 terms here. 2 of them have a v. 2 of them have an x. 2 of them have an s. And 2 of them have a z. But no more than 2 of them have anything in common. There's no term that even has, or there's no value that 3 terms share, much less 4. So what do we do? Well, this is when we employ a method that we refer to as grouping, factoring by grouping. I also in my class refer to it as factoring the long way. There's other shortcut methods, but this one is my tried and true, and it pretty much always works. So if we have to do it, we do it. So when we factor by grouping, we literally do that. We will group the 4 expressions that we have into 2 separate expressions separated by a plus sign, right? And we use the plus sign for the sake of ease, and you'll see why in later examples. So, excuse me. So now that we have it separated into 2 separate groups, separated by a plus sign, and by the way, the reason we're allowed to do this is putting parentheses between numbers and a plus sign doesn't actually change the value of the expression at all. If you remember PEMDAS, or order of operations, you can do what's inside the parentheses first, and then, do the addition outside the parentheses, but it wouldn't make much of a difference in the result, right? So, in this case, when it's multiplication or division, it's a bit different. But with addition, because of the commutative property of addition, I think it's called. I think that's what we called it. Anyway, it doesn't change the value of the expression. So now that we've done that, well, now we can just look at each expression at a time. So here, I'm going to block this one out, and now let's just look at the vx plus xz. Is there any term or any value that each of these 2 terms has in common? Well, yeah. We just said before, both of these terms have an x. So we can factor out an x from these two terms, and we would be left with a v plus a z. Right? Okay, that's easy. I'll go ahead and put my plus sign there that separates the 2 sides. Now let's look at the other side. Well, we have 2 terms. Is there anything they have in common? Well, yeah, we said earlier, these 2 terms share an s value. So we can factor out the s value, and we'd be left with v plus z. All right, that's pretty easy. Are we done? Well, no. And here's why. Hopefully now, this looks familiar based on the last video. If you remember from the previous video, when we had 2 terms in an expression where one term actually had a binomial in it and the second term had that same binomial in it, we saw that we could factor out that binomial and it would be left with the stuff on the outside. The same thing is happening here. We have 2 terms. It looks like 6 terms, but in reality it's 2 terms. A value multiplied by a binomial, that's 1 term, plus another value multiplied by another binomial, or the same binomial, that's the second term. We are allowed to factor out that binomial, v plus z, and we would be left with the stuff that was left over, x plus s. And now we have it in 2 binomials, it's fully factored, and we're good to go. And of course, it's always a good idea to check your work, so we can take our 2 binomials, v plus z times x plus s. We can use either one of the distribution methods. I know a lot of you guys prefer the box method. I hate it. It takes up too much space. I'm a FOIL guy, tried and true, so multiply our first two in each binomial. V times x is Vx. Then our outside, V times z is, V times s is Vs. And then inside z times x is Zx or Xz. And then last z times s is Zs. And we compare that to what we started with. And sure enough, even though it's in a different order, we have Vx, there's Vx, we have Vs, there's Vs, just in order inverted. There's Zx or Xz, whatever that is, and then Zs, Zs right there. And it works. There you go. So go ahead and pause the video for a moment and see if you can use this method to solve, to factor 10 and 11 real quick. I'll pause the video, take a screenshot of it, do what you need to do, take a few moments, solve or factor those. All right, so let's see how you did, right? So same method, put parentheses around the two terms. Now I'm going to do something a little bit weird on this one. I'm going to include the minus sign in here, so instead of reading minus 2x, I'm going to say plus negative 2x minus 6. That's going to help me in the long run. You'll see why here in a moment. So now we look at these as two separate binomials that we could find a greatest common factor in, rather than one set of four nomials, a polynomial that we're trying to find a common factor. So looking at the first term, we have x squared and 3x. We can see very quickly that both of those have an x in common, and that would leave us with x plus 3. And then on the second one, we have negative 2x and a negative 6. Well, they both are divisible by 2, but if you notice, they also are both negative. So we can go ahead and factor out a negative 2, and we would be left with negative 2x divided by negative 2 would be x, and then negative 6 divided by negative 2 would be positive 3. Now you see why I included the negative sign, because I have an x plus 3 and another x plus 3. If I had not included that negative sign, maybe I only factored out a positive 2, and I have an x plus 3 and a negative x minus negative x minus 3, and it wouldn't have worked. So now I'm able to do it. I'm able to go to the next step. The step like in the problems from the previous video. I have my x plus 3 binomial here and here, so I'll factor that out, and then I'd be left with x and then minus 2. And that's it. This last one here, just a little bit more difficult. I'll put the parentheses around it, just like we did before. We have negative 4x squared minus 20x. Both of these obviously have an x term in there, but they also, if you see, they're both divisible by negative 4. So let's factor out a negative 4x from each of these terms and see where we lie. Negative 4x squared divided by negative 4x would just be x. And then negative 20x divided by negative 4x would be positive 5. Check your calculator if you don't believe me. Then we look at the next term. We have, I did not leave room there. This one, a little bit easier, 3x plus 15. What do those both have in common? They're both divisible by 3. So we'll factor out a 3. 3x divided by 3 is x. 15 divided by 3 is positive 5. And again, just like in the previous two problems, we now have a situation where we know we can factor out a common binomial, x plus 5. So we can do that, factor out x plus 5. I'm going to do it over here. And we'd be left over with negative 4x plus 3. There you have it. That's factoring four-term polynomials in a nutshell. I hope this was helpful. Now that you've completed this one, you're ready to move on to the next video, which is factoring quadratics with 3 terms. The previous 3 videos have all built up to this last video, but I hope this was helpful. Please let me know in the comment section if there's anything I've missed or if you have any questions about anything. Thank you.